So in the first few minutes of this video, we'll talk a little bit about first two things we tried to cool the Hyper 9 motor that didn't quite do it for us, and then we came up with something that actually worked really well. We'll give you some detail on that, and then we'll move into where we are going forward. So it's August 29th, 2024. The boat's running great, but the motor still gets warm after about 10 minutes of running at high speed. My initial, or my second or third attack at cooling was to put in these two circuits of 1/4-inch copper tubing. We come from what is now a 6 gallon per minute 75 psi pump, and we go to there and we split it into two circuits and then out the side of the boat. When you look at the inside diameter of the copper tubing, it's only 0.19, I think, and you look at the area of that and it's really tiny. It's like 14% of the interior of a half-inch tube. So anyway, my plan now is to split it into 4 circuits and add as many more wraps as I can, which I can't add too many more, but I'm going to try. But I'm hoping the 4 circuits will give me an increased flow. As of right now, I don't know if you can see that, but that's how much water is coming out. The larger flow is what's coming out of the motor, and the lower flow is what's coming out of the controller. And that's really all I need to cool the controller, so I'm trying to nudge it into the to cooling the motor. So let's see how that goes. So I got the changes done. It's not very elegant looking, but it appears to be doing the job that I wanted to. So I've got the split coming off the pump. One side goes to the controller, the other side goes to this manifold on the starboard side. Breaks off into 4 flex connectors, and we've got 4 circuits wrapped around the motor. Then we go back off the other side. On the port side, we go to 4 flex connectors down to a manifold and out the side of the boat. So as I had hoped, we've got dramatically more water flow. I had only added about, we had about 85 feet of tubing on the motor, and I added another 20 feet. So I don't know if that's going to be enough to actually give me the contact I need or not, but I'm hoping the increased flow will take care of it. It's September 22nd, 2024. Boat's running great, but having a problem with keeping the motor cool. It is drawing 60 kilowatts or something when we're running up on plane. So conversation with NetGain, he suggested that the copper tubing that I'm using for cooling is only touching on little teeny tiny spots. And he said, let's try and fill the slots with thermally conductive filler of some sort. I'm using a caulk, and it's made by Silicone Solutions. You can see their product code there. I'm not supporting them or anything. I don't even know if this is going to work, but it's pretty expensive stuff, and I hope it works. So I finished putting the thermally conductive caulk all over the Hyper 9. All the motor slots are filled all the way around. I'm starting to lay out the copper tubing again. I've got 9 inches here. It's 27 inches per wrap. That turns out to be just about 80 feet of copper tubing. So I'm going to do my best to reuse the existing without kinking it. I set up this narrow plywood support on this end be careful. This is a heavy motor, especially when it's got the adapter on it. That thin thing allows me to just coil the copper tubing on there. I'm just going to lay it out and play with it a little bit for now. So I pre-fit the 4 circuits of copper tubing. I just took 2 of them off. And what I'm going to do is slide these 2 circuits over to this side, and I'm going to lay down a layer of thermally conductive caulk on that side, so that in addition to filling these bars, the tubing is actually sitting in a bed of caulk. It looks like, you know, I've got really good contact even without the bedding, but as long as I'm here and I've got the stuff, I think it's going to be a benefit. It's October 2nd, 2024. Motor's back in the boat. Ran it, shifted it. Life is good. Everything's working well. So we got 4 circuits hooked up. Got 4 on the input side there, and 4 going out the side of the boat. And we just water tested it. Got really good flow from both the controller cooling and the motor cooling, so we're all good. It's October 11th, 2024, and we're out for a ride. This is the first time we've had 3 people on the boat. The new cooling is installed, and it worked well. Took a really long time before it went into current limiting. But that's Navy Pier in Chicago. It's October 15th, 2024. We're done for the year. It's back in the garage. We're going to winterize it and move it over to storage here shortly. But just to follow up on the cooling, the last panel you saw, we were really happy with the cooling. Net Gain Motors was exceptionally helpful in finding that solution. And I'll show you what the steps are for next year. But just a couple of quick things here. See in the middle there, the one display is the Net Gain Motors compact display. Next year I'm going to switch that over to their touchscreen display, which gives us a lot more information. Specifically about, you know, motor temperature, inverter temperature, RPM, all kinds of good stuff. So we're going to do that next year. And like I said, the new cooling worked out pretty well for us, but we did still eventually go into current limiting at some point after we were running for quite some time. At some point, you may recall from an earlier video, I had 2 small fans mounted on the back of the controller that drop down into position when the controller is. I switched that over to one big fan, moves a lot more air. I think I'm going to move that down, and rather than have it controller mounted, I'll mount it directly next to the motor, and I'll use one of my thermometer controllers to turn that on and try and cool the end bell. It seems like the body of the motor is getting cooled well, and the end bell is what's causing the issue. So this is not exactly about motor cooling, but the number one question I always get, both online and from my friends here locally, is, you know, how fast will it run? How far will it go? How long will it go? I may do a video detailing what I do know. It's all sort of anecdotal at this point, but the bottom line is it'll go 25 miles an hour. You're going to see that here in the next video real quick. I think that's more than fast enough for this boat. Efficiency wise, at 5 miles an hour it'll run literally all day. The 54 kilowatt pack that we've got will run for about 10 hours if you're just idling around on a small lake. The next most efficient speed is flat out. I think the boat gets up on plane, gets out of the water, a lot less resistance, and that's the next most efficient speed. and you know, in that 23-25 mile an hour range. It'll go, I think, about 15 miles and still have a little safety factor to get you back home in an emergency. I don't know too much more than that. I think it's fine. You know, I think on a small lake, you know, being able to run 15 miles would be great. On Lake Michigan, that doesn't take you very far, but you know, it gets me from my home harbor into the downtown area and back, and you know, quite a bit more. So I'm happy with the performance overall, and here we go. We're just gonna close out the year and show you what it looks like going 25 miles an hour on a 18-foot boat on Lake Michigan. Have a good winter, everybody.